Okay, so now we will discuss plt.subplots, the whole grid in one go. So the approach just described can become quite tedious when you are creating a large grids of subplots, especially if you'd like to hide the x and y axis labels on the inner subplots. For this purpose, plot.subplots is the easier tool to use. Note that as at the end of subplots, rather than creating a single subplot, this function creates a full grid of subplots in a single line, returning them in a numpy array. The arguments are the number of rows and columns of, along with optional keywords, shear x and shear y, which allow you to specify the relationships between different axes. Here you will create a 2 by 3 grid of subplots where all axes in the same row share their y-axis scale and all axes in the same column share their x-axis scale. plt dot. Share y. Now, note that by specifying shear x and shear y, we have automatically removed inner labels on the grid to make the plot cleaner. The resulting grid of access instances is returned within a numpy array, allowing for convenient specifications of the desired access using standard array indexing notation. Access are in a two-dimensional array, indexed by row call. In for j in range ax j text 0.5 str j font size equals to font size equals to 18 is equals to now fig. Now in comparison to plt.subplot and plt.subplots is more consistent with Python's conventional zero-based indexing. Now we will discuss plt.gridspec, more complicated arrangements. To go beyond a regular grid to subplots that span multiple rows and columns, plt.gridspec is the best tool. The plt.gridspec does not create a plot by itself. It is simply a convenient interface that is recognized by the plt.subplot function command. For example, a grid spec for a grid of 2 rows and 3 columns with some specified width and height space looks like this. Let me show you. Grid is equals to plt.spec w space w space 0.4 h 0.3. So from this, we can specify subplot locations and extents using the familiar Python slicing syntax. plt dot plot grid 0 plt.subplot grid plt.grid 1 plt.subplot grid 2. Now we have this irregular subplots with plt.gridspec. So this type of flexible grid alignment has a wide range of uses. I most often use it when creating multi-axis histograms plots like the one shown here. So now we have a pretty long again code. Now create some normally distributed data. 0 1 x y b dot random multi normal. So now set up the access with grid spec. Dot figure grid is equals to plt dot grid spec for 8 space is equals to 0.2 w space equals to 0.2. Now main ex big add subplot grid -1 1 y big dot subplot grid then we have a square bracket, then we have the -1 0, then we have x tick labels equals to square bracket, then we have share y share y is equals to main ex. Now x is equals to hist is equals to, we'll copy that down from here. Now we will only change the number -1, we will change to 1, and we'll change this to y, we'll change this to, we'll change this to x, and we are good to go. Now scatter points on the main axis, main extra plot marker size is equals to 3 alpha is equals to 0.2. Now histogram on the attached axis x hist x 40 is type is equals to step filled orientation equals to vertical color is equals to x vert axis. Now y hist y hist dot hist y 40 is type is equals to step filled. Now orientation is equals to horizontal color is equals to gray y hist dot invert is equals underscore x axis, and we have and now we will enter and we will see a visualizing multi-dimensional distributions with plt.gridspec. Can't assign to operator. Here we have. So we have this. I guess we have skipped one, no? I guess we are good to go here. Done with axis, then axis. Y. Let me see.